class is going to talk about osmoregulation. Of course, you know water is a major component of our bodies, of most organisms' body. Okay, it's key that it gets regulated. We have enough water. Okay, so this is all about how water comes into and out of bodies. It's covered by a few things. So let's go through it. Okay, osmosis. First of all, remember that's the diffusion of water, specific to water. You have to know what a solute and solvent is, what makes up a solution. Cells are essentially solutions. Everything's in the cytoplasm is dissolved in water. Okay, so the cell is considered to be a solution. What does the dissolving is water inside. And then, of course, things that get dissolved are called solutes. Okay. Right, so with tonicity, things which have a lot of water and just a few solute particles. It doesn't matter what those solute particles are, salts, ions, or proteins, or whatever they are. Okay, high water, low solute would be hypotonic. So the hypo refers to the solute. Isotonic means that across a membrane, there's just about the same concentrations. Okay, things still do move back and forth, but due to their not just that Brownian motion they have. And things that are hypertonic means they have high solute concentration, okay, low water. Okay, so the basic rule is water always goes from hypotonic to hypertonic. All right? Okay, so example of this would be like a freshwater fish. Okay? What happens in a freshwater fish in a lake? Okay, it's got more solute particles in its cells, okay, than the pond water does, or the lake water. Okay, so what's going to happen there is the water is going to go into, okay, that fish. Okay, so fish has to have an excretory system, or kidneys have to be able to process that, so they have a very dilute urine to do that. But the idea here is water is going to go into that fish. In the ocean, it's just the opposite. So the water is hypertonic compared to the fish. Again, you can see these are relative terms. So if I could, I would put hypotonic here, hypertonic here. So fish have, saltwater fish have trouble keeping water, so they tend to lose water. Okay, so they have to have some adaptations to prevent them from getting dehydrated. So you can think about like when you're, if you're on a life raft in the middle of the ocean, you have all this water around you, but you can die of dehydration because if you drink that salt water, what actually happens, that water is going through your body. It actually draws water. That salt water will draw water out of your cells. Okay? So you actually become dehydrated by drinking that salt water. Okay? Whereas if you just drink pure water, of course, like out of a water bottle, okay, that's going to hydrate you. Okay, and if you get too much, then you have to go to the bathroom a lot. All right? Okay, so that has to do with so that's tonicity. Okay. Plants have what is called a turgor pressure. I just told you water always goes from hypotonic to hypertonic. Okay, so inside a cell, like do I have a plant cell here? Thought I had a plant cell. Yeah, right here, plant cell here. You always have solute particles inside there, so there's always going to be some solutes there. If you take fresh water and put it in there, then the cell's going to have this turgor. It's going to have a pressure pushing out against the cell wall. If you didn't have that cell wall there, then the cell would just keep expanding, and then it would just burst because of have too much water, because the water is just always going to flow in. Okay, so that brings us the next concept is this thing of water potential. So the overlying theme is water always goes from high water potential to low water potential. Okay, so water potential has two components to it. One is the solute potential, which we talked about up here. Okay, and the other one is called pressure potential. Okay, it's just caused by a physical pressure. Okay, so water potential is given the symbol psi. It looks like that little Greek letter psi. This water potential is equal to the pressure potential plus the solute potential. Okay, so whatever number you come up with here, okay, that's going to be that water potential. And it's always going to, if you have a membrane, it's between two different water potentials. Water's always going to go from high water potential to lower water potential. Okay. Now, if you have an open system like water in a beaker or something like that, there's no external pressure, that pressure potential is going to be zero. But of course, in here, where water's coming into this plant, that's going to create a little bit of pressure, backward pressure. Okay. So, solute potential, though, there's an equation for it. Okay, so it's maybe it doesn't show real good here, but in the PowerPoint you can see it. It's equal to, the solute potential equal to negative I, which is the ionization constant. Okay, so for molecules that's equal to 1. Okay, that's all you have to really worry about right now. C is concentration. R is a constant, okay, which is always going to be 0.0831. Okay, and then temperature in degrees Kelvin. Okay. Okay, because of the way it's set up, it's negative. It's always going to be negative. Okay. So the larger the negative number, of course, the lower the value of that water potential. So if you have this concentration is really high here, okay, that means you're going to get a pretty big number for this value. Okay, it's measured in bars. Okay, so if you have this situation here, I have -4 for this cell here. So let's say a potato wedge. Okay, so a potato, of course, has a bunch of cells within it. If you cut it off and cut a wedge and put it into pure distilled water, pure distilled water would have a water potential of 0. Okay, it's an open system, so that's 0. Okay, pure distilled water. Okay, it's going to have a solute potential of 0. Okay, so pure distilled water give me 0. Okay, and if the cell is -4, okay, 0 is bigger than -4, so water is going to flow into that cell. Okay, but at the same token, if you took this number, I don't have my marker with me, but if you made this number like you put a bunch of salt in there and made that -12, okay, then water would flow from -4 to -12. So it goes from higher number to lower number. -4 is bigger than -12. All right. So that's a little synopsis on water potential. Okay, and the key rule is water always flows from high water potential to low water potential.